Welcome to Physics World Online College, where we explain physics to the barest minimum, such that even a novice will be able to flow along and understand the concept of physics. In today's class, this is a new topic we're considering for SS2. We consider it as motion under gravity. It's a follow-up on the last equation we did, equations of motion or uniformly accelerated motion. Motion under gravity. Remember, if you have not subscribed, please do so. Click the notification bell close to the subscribe tab so that anytime we upload a new class, you will be notified immediately. Also, do well to share with your friends so that they will know that something good is happening here, and let them come and join us. Thank you. I continue with the class of today. Motion under gravity. This describes the motion of objects in space which are influenced by gravity as well as air resistance. Now, one would have imagined or believed or thought that if you have a heavy object and a light object, and then you climb to the top of a height or tower or a building and release the two objects, that both of them will move at different rates and then land on the ground at different time. That is what people imagine in the earlier years, about 400 years ago, until an Italian scientist called Galileo Galilei, when he took two objects, a heavy load and a light load, to the top of a tower called the Leaning Tower of Pisa, and then he dropped the two objects only for him to observe that both objects fell at the same rate, fell down at the same rate, and landed on the ground at the same time. So that gave rise to a new set of reasoning among scientists at that time. So why is it that the two objects, irrespective of their masses, fell at the same rate, at the same time, and hit the ground at the same time? So we came across the concept acceleration of free fall, or acceleration of free falling body. So that's what we're talking about. Let's take down some points. The motion of objects in space is influenced by gravity and air resistance. We can also call air resistance air friction. One would have expected that a heavy load and a lighter load, a light load, would move at different rates. Move at different rates. at different rate. Like I said, it was an Italian scientist called Galileo, who observed from the top of a tower called the Leaning Tower of Pisa that observed that a heavy load and a light load fell down at the same rate from the top of the tower and hit the ground at the same time. So what am I saying? If you have a piece of paper and then a stone, and you climb to the top of a high mountain, cliff or tower, and release the both of them, what we are saying is that both the piece of paper and the stone will land on the ground at the same time. Incredible. So what is responsible for that? Let's see that. What is meant by acceleration of free fall? This states that every object, let me say it this way, this states that in the absence of air resistance or air friction, every object moves at the same rate with the same constant acceleration, irrespective of their masses. This acceleration is the acceleration due to gravity. This acceleration is the acceleration due to gravity, and this acceleration due to gravity has a constant value, which we normally use as 9.8 meter per second square, or approximately 10 meter per second square. This acceleration due to gravity small letter g has a value of 9.8 meter per second square, or approximately 10 meter per second square. What am I saying? That the two objects, the piece of paper and the stone, released from the same height, fell down at the same rate, at the same constant acceleration. Hence, they reach the ground at the same time. So the mass of the piece of paper and the stone does not influence the time it took for them to move from the top of the tower to the ground. Good. So it is the acceleration due to gravity, or the force of gravity, that influence the body that are moving. That is why both bodies moving at the same rate of this value or this will reach the ground at the same time, irrespective of their what? Masses. But to remember, there is a condition here: in the absence of what? Air resistance or air friction. That is the condition. So we assume an ideal setting where the influence of air is minimal or negligible. Good. So this acceleration of free fall due to gravity can also be defined as the acceleration of free fall due to gravity g, small letter g, is also defined as the force of attraction. The force of attraction due to the Earth on a unit mass. What does that mean? It means that acceleration due to gravity g is equal to force divided by what? Mass. So we use this formula or equation to obtain the acceleration due to gravity in a place. And once again, we can use it to obtain another unit for what? Acceleration due to gravity, where force has a unit of Newton, mass has a unit of what? Kilogram. So this will give us another unit of g, acceleration due to gravity, as Newton per kilogram. So acceleration due to gravity has two units: meter per second square or Newton per kilogram. So this acceleration due to gravity varies from place to place. And the reason being that, number one, the Earth is not a perfect sphere, but elliptical in shape. Number two, the Earth rotates on its polar axis. I think we should take those 2 points. I said the acceleration due to gravity varies from place to place because, number one, the Earth is not a perfect sphere, but elliptical in shape. Number two reason is the Earth rotates on its polar axis. Good. So I'm just giving you two reasons. I think I can give you as an assignment, find out other reasons why acceleration due to gravity varies from place to place. In our next class, we're going to consider some points, statements, some facts about a body undergoing motion under gravity. We'll consider when the body is going up, we call it the upward motion, and when the body is falling down, we call it the downward motion. We'll consider those two aspects in our next class. Please remember to click the notification bell, to comment, to subscribe, and also to share. I will see you in our next class. Thank you.